Hi, Lester, Wushu Engineer. This is part 3 in my series in which I am building a functional armored jacket based on the samurai jacket design as portrayed in the preview of the upcoming game Cyberpunk 2077. For those who did not watch part 1, I recommend watching that first and then coming back to to this video, because I'm not going to repeat the background to this project in this video. Some of you may be wondering what happened to part 2 of this series. Well, I was going to be talking in depth about the materials used in the construction of the samurai jacket inner shell in part 2, and I did actually go through the process of preparing the video. It's actually all ready to go. However, I'm just not going to be releasing it. This is due to the fact that our R&D company may want to pursue this as a potential product. So I'm not going to be disclosing anything about the armor system that may be considered IP worth protecting. Although I won't reveal too much about the materials and their arrangement, there are certain things that I can reveal about the design and construction of the inner shell. The construction on the inner shell is not quite finished yet. I'm still tweaking the design somewhat, but it's about 80% complete, and I thought I'd make a video about it. As I mentioned in my previous video, I don't just want a jacket that looks like a samurai jacket. I want one that would actually function as a form of armor in a Cyberpunk or Shadowrun setting. However, in Australia, it is illegal for me to own a bulletproof vest, so I'm not designing it to be bulletproof. Instead, I'm designing my samurai jacket to resist conventional melee weapons, as well as the types of exotic powered melee weapons that are part of the Cyberpunk and Shadowrun sci-fi fantasy universes. So what are these Cyberpunk weapons like? The types of exotic weapon typically encountered within these alternate realities include power swords, laser swords, monofilament whips, various forms of tasers, powered gauntlets and exoskeletons, and chainsaw type weapons. Of course, the wielders of said weapons are also typically augmented human beings with enhanced strength, speed, and accuracy. So even conventional weapons in the hands of these augmented humans represent a considerably increased level of threat. Powered gauntlets and various levels of powered exoskeleton represent a similar threat to the augmented human beings, in that they typically enhance the wearer's strength and perhaps some other physical attributes. Power swords, vibroblades, and similar weapons generally involve vibrating, microscopically serrated crystal blades at high frequency to essentially abrade through a target at high speed. They're presented in the lore as being able to cut through certain types of armor. Chainsaw type weapons are as you would expect. They're technically advanced chainsaws designed for use in combat. Barring some technological improvements, they would function in pretty much the same way as a conventional chainsaw. Laser swords and other similar weapons typically involve concentrating a cutting laser along the edge of a sword in order to essentially burn through a target. Monofilament weapons include several variants such as swords and whips, but are all based around a very tough long chain molecule that essentially serves as a molecule thin, very fine, sharp cheese wire that can cut through most organic substances and some forms of soft body armor. Taser weapons function in similar ways to conventional taser weapons in the real world, barring perhaps a few technological enhancements and improvements in terms of their effectiveness. They're governed by essentially the same laws. So based on these potential weapon threats and the desired functionality of the armor, as introduced in part 1 of the series, we can sum up the requirements for the materials and arrangement of materials used to make the armor as follows. They have to be as light as possible in order to reduce the impact on mobility and fatigue of the wearer. This would suggest low density, high strength materials such as ceramics, composite materials, or some types of high-strength, low-density metals. They have to be put together in as flexible an arrangement as possible to reduce their impact on the user's manual dexterity and mobility. This would suggest fabric-based body armors or a flexible body armor arrangement. They need to be able to resist the impact, cutting, and penetration of conventional weapons in the hands of superhuman opponents. This would suggest the potential to spread impact forces over larger areas to reduce the damage from superhuman impacts. This would thus discount the use of fabric-based body armor, since these types of armor do not deal with back-face trauma very well. And of course, back-face trauma is essentially the amount of energy or force that actually is let through the armor and needs to be absorbed by the person on the other side. They need to be able to resist monofilament weapons. This would suggest some form of hard, rigid, crystalline or glass-like material with a densely packed atomic structure that the monomolecular wire would find difficult to cut through. Materials such as ceramics spring to mind. They would need to resist weapons such as the power sword or vibroblade. This would also suggest a hard, crystalline, or glass-like material with similar or greater hardness to the abrading elements of the power sword or vibroblade. Ceramics are a good option here again, and for the same reason. They would be able to resist or even destroy conventional chainsaw-type weapons, which would typically have teeth that are softer than most ceramics. They'd have to be able to resist the intense, concentrated heat of a laser sword, long enough so that the strike would not be able to penetrate the armor. Once again, ceramics are a good candidate since they usually have very high melting points. They would also have to be able to short out a taser weapon or insulate the wearer from its voltage or both. In this case, metals are good candidates to short circuit the charge of a taser, and ceramics are really good insulators. And then finally, since the armor will only be protecting specific areas of the wearer's body, the traditional concept of deflection may prove dangerous, because deflecting a weapon impacting the armor may simply deflect it directly onto the body of the wearer. The armor will thus have to catch or bind a weapon strike and not allow it to deflect. The armor itself will thus have to deal with the energy imparted by the weapon. This would suggest a very solid type of armor deployed in an arrangement that distributes impact forces to a larger area. Conventional fabric-based armor systems are not very resistant to edged weapons on their own anyway, so this kind of ruled them out as an option. Instead, I looked to the traditional Kiko armor pattern used to make some of the armors worn by samurai and others in historic feudal Japan. It's a pattern of hexagonal plates, often made of metal, separated by mail or bound between two layers of cloth, allowing flexibility in the plate. I thought it was only fitting and right that this would form the basis of my samurai jacket. It was exciting for me to incorporate some of these historic design ideas into my system. It's a bit like taking the idea of the historic samurai and bringing it into the futuristic world of cyberpunk while still paying homage to the traditions and knowledge of the past. Instead of the hexagonal pattern in standard traditional Kiko plate, I adopted a simpler square pattern for my plates. This is a compromise essentially to reduce the complexity of the design, since the armor would be limited to only certain areas. This still allowed for a great deal of flexibility. I decided to use square Kiko plates made of 4mm thick titanium as the foundation, glued between two sheets of Kevlar fabric to allow for the flexibility. As mentioned in part 1, the inner shell will be worn under a shirt and will provide the base layer of armored protection. The outer shell will be the ipso facto obvious jacket part of the samurai jacket and will provide some armor for the areas that the inner shell doesn't cover. The inner shell provides protection essentially in a rectangular area in the front and back of my torso. very similar to a standard ballistic plate carrier, but with certain modifications to the design based partly on historic samurai armor. I've been quite surprised by the level of mobility that the system allows. Let me show you some examples. In addition, the system is quite low profile, enabling it to be worn below another garment without drawing too much attention. As you can see, low profile concealable body armor is a good idea for a Cyberpunk solo who doesn't have cybernetic armor implanted and who wants to go covert. Due to my use of 4mm thick titanium plates in the construction, it's not lightweight, weighing in at just over 7.5 kilograms. But the weight is distributed well and does not hang on the shoulders. It's actually quite comfortable to wear. After drawing inspiration from the design of the inner shell from traditional samurai armor designs, I felt I'd like to continue this in my design and build of the outer shell. So I'm going to deviate somewhat from the look of the samurai jacket as portrayed in the Cyberpunk 2077 trailer by incorporating more pronounced samurai armor inspired shoulder plates, articulated side plates perhaps, and perhaps even splint style vembraces. I'm actually getting more and more excited by the project as it progresses. I hope you are too, and I'll see you next time. Cheers.